So the next thing we're going to do is we're going to take percentages and convert them into angles so we can find arc measures. So this is an example of a pie chart. This looks like this is somebody's budget, and it's like the percentage of their budget that they're spending on different categories. So all the way around the circle is 360 degrees. So we're trying to figure out what percent of 360 degrees is each of these angles. So what we're going to do is we're going to take each percent and turn it into a decimal. So you move the decimal place 2 spaces to the left to turn it into a decimal. So 48% becomes 0.48. Then you're going to take your decimal, 0.48, and multiply it by the total, which is 360. All the way around the circle is 360 degrees. So 0.48 times 360, this is 172.8 degrees. Which makes sense because 48 degrees is about 50%, about halfway. And we know that halfway around a circle is 180 degrees. So 172 is a little bit less than 1/2 of a circle. So that makes sense. You should be able to logically decide whether or not your angle measure is reasonable compared to the percentage. So I'll do this red portion with y'all. So I'm going to change 19% to 0.19. I'm going to multiply it by 360. 0.19 times 360 is 68.4. So go ahead and take all of those other percentages and turn them into an angle. Okay, and then you should be able to double check. You should be able to add up all of these angles and make sure that they add up to 180. Okay, so the measure of arc CB, the measure of that central angle is 68.4, so that means that the measure of that arc is 68.4. And if it's less than 180, it is minor. Try part B and part C on your own. Find the measure of arc CF and the measure of arc ACE on your own. Okay, the measure of arc CF goes from C to F. Has to be that minor arc. Remember, when it's 2 letters in your arc, it has to be a minor arc. So you might be thinking, Ms. Briscoe, how do I know that I'm not going this direction to get from C to F? Well, that would have been a major arc. And if it's a major arc, you have to use 3 letters. So if it says 2 letters, I know that it has to be the shortest distance between point C and point F, making it this minor arc. So I'm going to add this green part, this purple part, and this blue part all together. So those 3 angles, 32.4 plus 32.4 plus 36. And that gives me 108 degrees. The measure of that arc is 100.8. I'm sorry, not 100.8.
Pardon this interruption. If you are parked directly in...
Sorry about that. Just keep me on your toes. Got interrupted by the announcements. Okay, so arc ACE. Again, the order matters. We're going from A all the way to C and then to E. So it's everything except this blue and orange sliver. That's 15% of your pie chart. So this whole arc would be 85% of the pie chart. 100 minus 15 is 85. So I can do it that way. You end up getting 306 degrees for the measure of arc ACE, and that is most definitely a major arc. This one is minor. Okay, so hop on over to your formulas and equations part. We're going to learn the formula for arc length. So we talked about how there's a difference between arc length and arc measure. Arc length is if you were going to measure the distance between 2 points on a circle. So it would be in inches or feet or miles or yards. It's an actual distance, an actual length. The formula for arc length is a portion of your circumference. So it's arc length over circumference. That ratio of the arc length to the circumference is proportional. That ratio is equal to the measure of the arc. Remember, the measure of the arc is in degrees over the total number of degrees in a circle, which is 360. It's kind of like part over total, part over total. So the formula for circumference, if you forgot, is 2 pi r, or you could do pi times the diameter. And then the measure of the arc is, remember, the same as the measure of that central angle, so we can use theta, or Greek letter theta, to represent the angle. The arc length over circumference equals that angle over 360, or the measure of the arc. The measure of the arc length are, the measure of the arc, and the central angle are the same. Okay, so we want to find the length of arc AB. So literally, how long would this arc length be? So arc length is what we don't know, so we're trying to find the length of the arc. I'm going to call that x. Arc length over circumference. 2 pi times my radius. My radius, remember, is the distance from the center to the edge of the circle, so my radius is 12. Arc length over circumference equals my central angle over 360. The measure of my arc over 360. So that's 45 over 360. I am going to cross multiply. So 360 times x is equal to 45 times 2 pi times 12. And 45 times 2 pi times 12 is 3,392.92. And so then to solve for x, I'm going to divide by 360 and get my arc length to be 9.42. That's how long that arc length is, 9.42 units. So if it had been inches or feet, this arc length would have been in inches or feet. The last example, this time I'm telling you the arc length. This is your arc length. Your arc length is 6 inches. So instead of plugging x in for my arc length, I'm going to plug x in for my central angle, for my measure of my arc. I don't know how many degrees this is, so that's what I'm solving for in this equation. So the same proportion. Arc length over circumference equals the angle over 360. I know my arc length is 6, so I'm going to plug it in the numerator. I know my circumference is 2 times pi times my radius, and my radius is 3. Arc length over circumference equals my angle, which I don't know, so I'm going to call it x, over 360. Arc length over circumference equals my angle over 360. Arc length over circumference equals the measure of the arc over 360. Same deal, cross multiply 6 times 360, which is 2,160. And then 2 times pi times 3. We'll just leave it in terms of pi for right now. That's 6 pi x. I'm going to divide both sides by 6 pi. Now I'm going to put the 6 pi in parentheses. And then that will give me x is, make sure you put it in parentheses or else you're going to get a weird answer. You're going to get 114.59 degrees. 114.59 degrees. Or that measure of angle AOB. 114.59 degrees.